at the bottom of page 2, we are going to define the number e. Okay, so e is not only a letter, but it's also a number. Okay, if you open your textbook, okay, what's in the box is how your book defines e. It says the number e is defined as the number that the expression 1 plus 1 over n, that quantity raised to the n power, approaches as n approaches infinity. Okay, that's quite a definition to understand. Okay, that probably doesn't make any sense to you. If you went on to 1325, that math class, which is basic calculus or business calculus, that notation might make more sense to you. Okay, so even though this is the definition provided in your book, you don't have to understand what that is saying. Okay, basically what I need you to know, you do have to be very familiar with the number e. Okay, especially if you're going on to Math 1325, you will see e all the time. Okay, e is a number like pi. Okay, we know pi, it's about 3.14. One of the hallmarks of pi is that it's a decimal that goes on forever and it never repeats. Okay, and so e is the same kind of thing. It is a decimal that goes on forever. It never repeats. Okay, so pi is about 3.14. E is about 2.71. Okay, so you can see right here, I have it kind of the first few decimal places written out for you. It's about 2.71. Okay, so keep in mind it's a number just like pi. Okay, we are going to be working with e quite a bit in the remaining part of the semester. Okay, so when you work with e, you need to work with e. Okay, don't round it to 2.71. It can mess you up. Okay, so when you see e, just write down e. Know in the back of your mind it's about 2.71. Okay, so at the top of the next page, we're going to try to sketch a graph of e to the x. Okay, notice it is a simple exponential function. Okay, it's a number raised to the x power. Okay, so our base here is e. Okay, so that's the base. Okay, so we're just raising approximately 2.71 to a power. Okay, all right, so we're going to make a table of values. Okay, so again, we're going to pick our same kind of x values that we've been picking. Okay, so I won't pick as many. I'll pick -1, 0, 1, and 2. We're going to take each one of these x values and plug into the function e to the x. Okay, we're going to get decimal answers. We're going to have to use our calculator here. Okay, so we'll get approximate y values, and then we'll just have to eyeball the points that we plot. Okay, let's start with 0. Okay, so we're going to get, if we plug in x equals 0, we'll get e to the 0 power. Anything to the 0 power is 1. Okay, so this graph will also go through the point 0, 1. Okay, so then if we plug in 1 for x, we're going to get y equals e to the first power. Okay, so we know that's about 2.71. Okay, so we're going to plot the point 1, approximately 2.71. And then we're going to plug in 2 for x. So we'll get e squared, which is e times e. Okay, you're going to have to go to your calculator. Like I said, there's a couple of e buttons on here. The one you need to use is the one, if you see an ln button on your calculator, that's logarithms, that's coming up. But above it, like in blue right here on mine, I see e to the x. So I have to use the second ln function, and it brings up e to a power. So I can do e squared. Okay, so that decimal approximation, it's about 7.39. Okay, but that's how you can use e on your calculator. Okay, so we'll say this is about 7.39, I think it was. Okay, so if x is 2, the y value is 7.39 approximately. Okay, and then if we plug in -1 for x, we'll get e to the -1. Okay, I'm just going to pop that in the calculator. Okay, so let's see what we're going to get. Again, second ln will bring up e to a power. So e to the -1 power is about 0.37. Okay, so we'll use that. Okay, so there we go. So we'll plot the point -1, about 0.37. Okay, again, because the y values are decimals, we're just going to have to eyeball these points. Okay, e to the x definitely goes through 0, 1. Okay, And then we're going to have to do 1 about 2.71, and then 2 about 7.39, okay, and then negative 1.37, okay. So again, what you need to get out of this is that e to the x has the same basic shape as both 2 to the x and 3 to the x, okay. So one side climbs very quickly, the other side levels off at the x-axis, okay. So very, very similar shape, just different points that the function goes through. If you go on to take 1325, I keep bringing it up because e to the x, that is the most popular function in calculus, okay. So you will see it a lot.